Hi guys, in this video we're going to solve the mathematics paper 1 which was written in June 2021. So this is the supplementary examination. So I want to solve this question paper in parts. So let us get straight into question 11. So if you have a look at this paper here, question 11, right? Look at question 11. This is question 1, 2, right? Question 11 is based on counting principles and probability. So let us have a look at question 11, right? Have a look at these questions, right? Now I've cut these questions into pieces so you can see much better, right? So topic, probability and counting principles. Let us have a look at question 11.1, which is basically June 2021 Supp paper. So that's paper 1. Now, two events A and B are such that events A and B are independent. So a very good question. What does independent mean, guys? Independent means that the probability of A times the probability of A and B becomes the product of the two probabilities. In other words, probability of A times probability of B. So now we got probability of not A is 0,4 and the probability of B is basically this independent means probability of A and B is equal to the probability of A times the probability of B. We got the probability of not A. So remember, the probability of not A plus the probability of A is equal to 1. So if we want to find the probability of A, we can say that is just 1 minus the probability of not A. And the probability of B is 0.3. We want to calculate the probability of A and B. Simple, guys. So I've already given you hints here. So in order to calculate the probability of A and B, what we can say is the probability of A and B is probability of A times the probability of B. Now the probability of A is basically 1 minus the probability of not A. So you can use this bar on top of A to represent not. So the probability of A is 1 minus the probability of not A, which is 0,4, times the probability of B, which is 0,3. Then you got 1 minus 0.4, which is 0,6 times 0,3. If you use your calculator, 0.6 times 0.3, you should get 0,18. So let us calculate this. So 0.6 times 0.3. So we are getting 0.18, which is correct. You can also write, remember, 0 point or 0 point like this. It's the same thing, which is 0.18. Looking at the next question, 11.2. So what do we have here? We have a three-way Venn diagram. So I'll just make this a bit smaller. Now whenever we have a three-way Venn diagram, it's good to read the story. So what we have here is a survey was conducted among 150 learners at school. So in total there are 150, is right, capital N is equal to 150. The following observations were made. The probability that a learner selected at random will take part in only hockey is 0.24. Hockey only is this region they are talking about, that is correct. But usually when you're filling in this Venn diagram, we work in this order, like we fill in all the threes where everything is, then we go to the twos and then ones, right? The threes, then the twos, and then the ones when you're filling in information. So let us read where everything is all together. So in this diagram where all three diagrams are intersecting, which is at A, so I'm sure they'll have something about A here. So 15 learners participated in all three activities. So the value of A should be 15 out of 150, right? Because That's what they are telling us, and they are total. If you want to calculate a probability, you'll put 15 out of 50. You can see it's a probability Venn diagram, so we can't write 15 there. So 15 out of 150, you should get 0.1. So we already have the value of A, guys, right? So remember, we filled in the 3's, and look at, since the diagram is already filled in, you can just have a look at the information provided, right? Hockey and debating but not chess. So hockey and debating but not chess, so remove this part. So we have the hockey and debating but not chess is equal to 0.14. Remove the chess part, in other words, remove the entire circle of C. 0.14 is already represented. This one and that one is already represented. Debating and chess but not hockey is 0.12. That information is already there. Hockey and chess but not debating is 0.02. This information is already there as well, right? Looking at the next one, the probability that a learner selected at random participated in at least one activity is 0.7. At least one activity basically means chess or hockey, or, so they are talking about the 3 circles of A. Now the 3 circles, the areas of each one here, or the probabilities of each region here is equal to 0.7. At least one activity. So you can have at least one activity means one activity or 2 activity or 3 activity or all 3 activities. All right. So they're talking about the area inside here, and they're telling us the area of this entire thing is 0.7. The number of learners that participate only in debating is the same as the number of learners who participate in chess. So there's it here, B and B, that's also represented. Debating and chess, equal number for them only. Then obviously this entire thing sums up to 1, so the value of M should be 0.3, because this entire thing is 0.7. The probability of the sample is 1. So now we can answer our question because we understand the diagram. Right, so determine A, the probability that a learner selected at random participates in all 3 activities. So the value of A is 15 out of 150, which is equal to 0.1. So problem sorted, the value of A is 0.1. Next one, determine M, the probability that a learner selected at random does not participate in any of the 3 activities. So therefore M is equal to 0.3. We got the 0.3 because these 3 circles added up together with 0.7. Then I'm sure the next question will be to calculate the value of B. Let's see. How many learners play only chess? So first, only chess is B. Right, so we need to get the number of learners. Remember, we will end up with a probability. So we need to work out the number of learners that play chess only. So we can add up everything over here. So let us add up everything there. So we got 0.24 plus 0.14 plus 0.1. Right, so 0.24 plus 0.14 plus 0.1 plus 0.02 plus 0.12. Right, we are getting an answer of 0.62 plus B plus B. So 0.62 plus B plus B. So you can just say 0.62 plus B is equal to 0.7. Remember, because each of these regions added up together gives me 0.7, right? So now 2B is equal to, you can take 0.7 minus 0.62, right? So 0.7 minus the answer should get 0.08, and divided by 2 we'll get 0.04. But remember, the number of learners that play chess only is B. Therefore chess only, the number of learners that play chess only is equal to, this is 0.04 times the total number of learners, which is 150, or 4% of 150. So divided by 2, and you can say times 150. So we have 6 learners that play chess only. How many learners play only chess? So we are talking about this region over here. Only chess is 6 learners, so basically 6 learners out of 150. So that's your solution, right? 6. Let us look at question 11.3. A 3-digit number is made up by using 3 randomly selected digits from 0 to 9. So we have numbers from 0 to 9, which means there are 10 numbers in total. Right, so we got total 10 numbers. Determine the total number of possible 3-digit numbers greater than 100 that can be formed. So we're looking for numbers that are greater than 100. So how we usually do this is we use the dash method. That's what I use. Right, so I'll create 3 dashes to represent the 3-digit numbers. Now remember, we're choosing a number which is greater than 100, right? And no digits may be repeated. We cannot repeat the digits. So if I'm choosing numbers greater than 100, obviously I can use the number, I can't use the number 0 here, right? So I can only use numbers from 1 to 9, right? So those are my possible numbers that I can use, numbers from 1 to 9, right? So there are 9 possibilities here. Then in the second one, provide now because I have used in the second one, I can use any one of these numbers here, right? I can use any numbers from 0 to 9. Now because you got 10 numbers here, now remember you have already used up one number in the front. So remember you have a total possibility from 0 to 9. Any number can go here from 0 to 9. But since you used up one number here, you only have 9 possibilities. Right. Now in the last digit, we got numbers from 0 to 9. You can use that. But now you have already used up 2 numbers here, right? You have already used up 2 numbers there. So we are left with 8 possibilities. So if we calculate 9 times 9 times 8, we should get the answer. So 9 times 9 times 8. So we're getting 648 possibilities. Yes, because the digits may not be repeated. Correct. 11.3.2. Determine the total number of possible 3-digit numbers, both even. So the number needs to be even and greater than 600 that can be formed. Yes, how can we solve this? We need a number which is greater than 600 and needs to be even and greater than 600. So let's start. Alright, so I'm still going to use the dash methods, but just trying to figure out how can we solve this. Both even and greater than 600, and digits may not be repeated. So we know even numbers ends with 0, 2, 4, 6, 8. Right, and numbers greater than 600. Alright, so let's try. Let's start the number with 6. If a number starts with 6, right, then if a number starts with a 6, right, then I only have one possible option here because I'm starting the number with the 6, right? Why am I starting with the number with the 6? Because I want the number which is greater than 600 and it needs to be even. So I only have one possible choice here. Now remember, you can't use a 6 at the end because then you'll end up repeating this. So what we have over here is we can only use numbers which is 0. We can use 0, 2, 4 and 8. So you only have 4 numbers there. Right, now you used up a 6 and you used up another number here, so you left with 8 numbers. In other words, from 0 to 9 you had 10 options here, but now you used up one number here, one number at the end. So in total we got 32. Now what if the number starts with a 7? If the number starts with a 7, you got one option there, but at the end you can use any one of these numbers like 0, 2, 4, 6, 8. So you got 5 options there. Now because you have used up one number in the beginning and one number at the end, you only left with 8 numbers out of 10, because digits may not be repeated. So you got 40 here. Next one, if you start with an 8, if you start the number with the 8, then so you got one option here, but you can't use the 8 at the end. Meanwhile, you can use all the other numbers, right? So you can use up all the other numbers. You've got 4 options there, and since you have used up 2 numbers here, you're left with 8 numbers out of 10 numbers. So that should give you 32 as well. And then if a number starts with a 9, right, so you have one option here, and you've got 5 options at the end, because you can use 0, 2, 4, 6, 8, and since you have used up 2 numbers, you're just left with 8, and 8 times 5 is 40. So total is equal to 40 plus 40 plus that should give me 64. So what we have here is 40 plus 40 plus 64, and my answer is 144. Right, so this was question 11, guys. I hope you understand. I will create a playlist and make sure to watch the rest of my videos on this paper. I will post them as soon as I do them. Watch out for the link in my description as well. I hope you understand, guys. Thank you.